Welcome to this session on what's new in server and database, a faster data stack. This is number 2 out of 4 sessions on news in the server and database part.
Should we get started? I think we should, because
Yes.
we have lots of cool stuff to cover here. Let's talk a little bit about companion tables prior to this release. In the way the data model where we store table extension data has always been that we store each table extension in its own table. And then at runtime, we enforce a one-to-one relationship between the base table and each extension table. The primary key for the base is also the primary key for all companion tables. That's the name we call these physical tables. Now, when we then fetch the data from the AL runtime, we will simply join all these extension tables unless you use partial records. And this means that the execution time, because of these joins, will grow linearly, probably, with the number of table extensions. And the SQL Server Query Optimizer has a hidden limit around 7 or 8 joins, where it will stop optimizing and simply use one join algorithm. And that means once you get past that step, you might have suboptimal plans, but there's nothing really you can do about it, or we can do about it. The previous only way to get out of this join issue was to use partial records. This would be a way to prune either fields or joins.
Yes. And the reason why we actually had that model was that it made installation, uninstallation of extensions very easy, because we could basically just leave the table behind, because that would have no effect on the other tables. But we decided that for performance reasons, we wanted to change this model. Exactly.
So there's some behaviors of this model. An n-way join of one-to-one tables is slow. Now, normally, if you have joins, it's very often that you have a driving table, which is big, and some smaller tables, which have low cardinality, which are lookup tables. In this model, the number of rows in the base and the things you join to are the same. And that's why this can never be fast. If you have a customer who has installed a number of apps and extensions, not really any of these extensions are to blame for a performance issue, because it's just built into the model. And there's no really easy way to mitigate this problem. You can't ask a customer to uninstall functionality to get speed. It's the only way we could solve this would be the AL runtime, the platform to do it.
Yeah, and also we sometimes heard partners asking, so should I create 3 extensions or 1 extension? Because it's logical for me to split it into multiple, but that means it'll be slower. Now, with the new model, I can reveal that it doesn't really matter anymore, seen from a performance point of view.
Exactly. So we changed the model, the data model for table extensions, and now we simply have the base table, and we have one companion table that stores the fields for all table extensions. And this minimizes the use of joins, because you will at most have 1 join instead of n joins. And it severely affects, in a good way, the performance of database operations. Delete operations 2 to 5 times faster, insert performance twice as fast on the measurements we have. Modify can be also 2 times faster, and read performance is definitely where we see the most impact. But be careful when you measure here, because the NST, the server, caches data. So it can be hard to measure. At least you need to flush all caches before you do your tests. And I think Jens is going to talk a little bit more about the read performance improvements. So this is how the tables look prior and now in version 22. You see here in version 22 that you have the base table, and then for each of the table extensions you would have their own table. Now in the new schema, we simply have the base table, and then we have one companion table that stores all the fields from each table extension.
And you'll also notice that in addition to only having one table and one join, the database size actually also decreases quite a bit because there is only one copy of the primary key, there is only one copy of the row version, and then of course you have the individual fields, meaning that the overall storage usage is smaller.
Correct. So what's the expected performance impact? Let's look at this graph on the right. You can see version 22 is the blue line, and the orange line here is version 23. And you can see the read performance simply scales in the old model almost linearly with the number of table extensions, whereas it looks much flatter here for the new model. First of all, why do we see this change here? That's because it's of course fastest. Well, this is because you see one join, so there's a little bit there. And then the increase for the new model is only for the fields, the extra fields you read, whereas in the old model, you also get that penalty from the joins.
Yeah, and the reason why it takes longer to read more fields is that there'll be fewer rows in each data page. So normally you would have to read more data pages just to get the one extension table when it grows larger.
Yeah. Then why this? Why don't we see a larger increase in performance for, let's say, modify, insert, delete, anything that is not read? This is typically because on the database you would see a huge impact, but on the NST and the AL runtime, we often need to run events, and that means that most bulk operations will actually not be in effect. And that's the primary reason why we don't see a huge benefit here.
And that's also why it's really hard to state how much faster will this be. Read does not invoke events, unless of course you have an on-after-get record trigger, but usually just in normal AL code there are no events evolved. The moment you have modifications, we have events that very often actually determine the performance of insert, modify, delete.
So your mileage will vary with this. You can have different number of fields, different sizes of fields, triggers. You might have different triggers running. You might have tons of indexes, a few indexes. So whether you would get a twice or a 5x or a 10x, really up to how your code is organized and the data you have.
Yeah, and also remember that if there is only one extension, you won't see a difference. It doesn't really matter until there are multiple extensions in play.
So what's the record we've seen in prod for number of table extensions? Do you remember?
Oh, it's 70, 80, something.
70. So if you are that customer with 70 table extensions, you would go from a 70-way join to a one-way join.
Yes.
And I hope you're listening out there.
I feel sorry for that customer if it's on one of the larger tables.
Yeah. All right. You might wonder, but wait a minute, what about cloud migration? Since you're changing the schema, like how can we migrate from earlier versions using the cloud migration tool? We upgraded that, so all good. Version 23 exposed the mapping from previous versions. We updated the tool. So these Azure Data Factory flows now, they know about the new and old data models, and cloud migration is fully supported, also from previous versions as it used to be, or as it should be.
Yes. You should be aware for on-premises, since we are changing the data model, there is quite a bit of data writing going on during upgrade. So when you upgrade an on-premise installation, you should probably expect that to take a little longer than, for instance, the version 21 to 22 upgrade.
Yeah. But wait, what if we are on-premises and we have integrated directly to the database with data warehousing, ETL tools, business intelligence? What do we do? Well, First of all, maybe you shouldn't because it's not supported, but that's not really a good answer. Because of course, if you have been involved with Power BI or other tools, it would be natural to point it to your database on premises. The way to get out of this once you are on a new model is that you can mimic the old schema with database views. So it's possible for anyone reading the data, they don't know whether they're reading database views or the physical model. And there are already code samples out on GitHub, so search for that. At the time of this recording, we don't have it on BC Tech. We might get a version of that on BC Tech, so let's see. But if not, search for code samples to create database views, and I think that will probably unblock most of these things for you. So we had a huge marketing splash on partial records and SetLoadFields. Like, this is the thing that will solve everything. And it did solve some things, but now we've solved it in the platform for the joins. So you might ask, is SetLoadFields really needed anymore?
You can say that in some cases, it will have much less effect. If you used it to remove the join statements, then that is actually done now by the platform, unless you remove the one join to the one extension table. But SetLoadFields also limits the fields loaded. So that means there is less data to transfer, there is less data to cache, and you can actually also hit covering indexes. So particularly for tight loops where you need to process a lot of data, it'll still make a big difference, particularly if you can hit an index. So overall, continue using SetLoadFields. You don't have to sprinkle it all over your code base, but when you have performance critical code, you want to control which fields are loaded. You want that part to be as fast as possible. Whereas for the generic situation where you didn't optimize, now the platform helps you.
Speaking of helping, we had our own app teams asking for this, and it might help you as well. So if you write code and you're the owner of the base table, it might be that you want to be able to set to load all the base fields. So we now have a new method that allows you to do that. And we know developers are lazy, and that's a good thing. That's what we want. You to write as much code with as few statements as possible. So maybe this new method will be for you as well, to lower your maintenance cost on your code and still make it faster.
And there is an example here where on VAT entry, it's just called SetBaseLoadFields, and then setting the range, and then doing a find set, and there it is looping. Now, particularly if the code inside the loop changes, then before with the SetLoadFields, you would have to remember to go back and change which fields you loaded if you started accessing a new field inside your loop. Now, this one will at least remove the join, but again, if this is performance critical code and you really want to optimize, then you can use the SetLoadFields to minimize what is cached and loaded.
Yeah. And is this an example from the base app?
Yes.
So this is actually something you can search for in the base app code and see the actual example how it's being used.
Yes, so if you're in doubt, you don't really know which fields, but you know that this is just my code, I'm not raising events, then putting in a SetBaseLoadFields is a safe way to go.
Cool. So key takeaways from this new extension schema. The main thing here is there is really no action on you. Right? We just made things faster for all code.
Or maybe the only action is to stop worrying about whether you should put in 1 or 3 extensions.
That is true, yeah. And you would, as Jens said, if you only have one table extension, you won't see a difference. If you have 2 or more, you will definitely see it, mainly on read, maybe even on logging. Let's see, we need to measure that. Cloud migration is fine. On premises, you need some work if you access SQL tables directly.
Yes. Now, as part of this, we also realized that if you leave data behind, then it now has a performance impact. Because before, as I mentioned, it would just sit in a separate table. Nobody would really care about that table except if you're looking for database storage. But now it is part of the extension tables row. So if you've uninstalled an extension but did not delete the actual data, then it uses database capacity, and it also makes joining with this extension table slightly slower. So we've added the ability to remove it if you had forgotten to mark the delete extension data when you uninstalled your extension. It is placed in the installed extensions. Now that can actually be a little sarcastic because you're deleting stuff from the not installed extensions from the installed extensions, but it was still the most natural place for us to put it, where you can delete the orphaned extensions data, and then it'll show you which extensions still have remnants in the database, and you can then decide to delete it, and that way it gets removed. This also means that after you've done this step, if you reinstall the extension, then you won't have the data, and that was actually how you had to do it before. If you had forgotten to delete it, you needed to reinstall, delete, and then uninstall again, but that is no longer needed.
Cool. A lot about data, reading, writing. Another part of data is logging. And we actually also have some cool new stuff going on here.
Yes, we have enabled the ability to change the logging model to minimize, or at least to automatically take fewer logs in AL. And this is a thing that benefits all usage scenarios, web services, integrations, background jobs, and interactive sessions. And of course, there are two ways that you can improve the logging situation. You can log less, or you can just make your code faster. So the first part we just talked about here will actually help on logging because you hold the logs for shorter if the code is faster. But what do we talk about when we talk about the new logging model? Well, before, and this may not be obvious to everyone, we had the approach that the moment we entered into a write transaction, then we would start taking logs on any table that was modified. So in this case here, first it'll do read uncommitted, then you do an insert into that table, and then when you read from that same table type, in this case the currency table, then that would be read with an update log.
Can I say something here?
Of course you can.
Because I think the gotcha here is when I saw this code sample, I was like, what? So the update log is actually taken on a different records instance. You can see cur2 is a new instance of that. So why would you take a log? Well, this is because the old behavior was that whenever you do a change on a table, then all new instances on the same table in the same session will inherit the log. And I think that was a gotcha for many.
Yes, it definitely was. And there are some deeper lying reasons for that. For instance, when you pass a record from one function to another, if you don't pass it by var, you get a new record. So now if you did something down there, you actually had a new record. So there are some reasons why it was like this. And we've had to do some tricks in order to keep the old behavior. But with the new logging enabled, then after modifying and entering after the insert statement here, then further reads on other record instances pointing to the same table will now be done with a read committed. So for a given record type, as long as you have not entered into a write transaction, then all reads have the read uncommitted hint applied. And then when the data has been written, or some data has been written to the record type in the current transaction, then further reads will have the read committed hint applied. Now, you can still do log table. Log table has not changed. That is your way to say, well, I still want this automatic application of update log. So if log table has been called, then further reads will have the update log hint applied.
And this is important because when you look at the base app code right now in version 23, there will still be a lot of lock table statements sprinkled all over that code. But we are changing that with the app teams in the next releases, so that we will try to make the base app much more concurrent friendly and less locking. And you should do the same for your code. If you have, of course you have, because before this you couldn't otherwise, right? You would have lock table sprinkled over your code as well. And you need to look at these critically and see, do I really need to do exclusive locks with lock table, or can we maybe do better and do the new locking regime?
Yeah, and you talked about the different record instances, and you can control the locking behavior on an instance level by using the read isolation property, which is one way to avoid calling lock table. You can basically opt out, saying I want to read this with an update lock, but I don't really want it to do a lock table.
Correct.
And here is sort of a summary of the before and after situation. We talked about the update log versus read committed, and basically the effect is now that you'll only acquire shared log when reading other data from that table, and that means that you can read other data from that table and other sessions can do the same. Now the record that you're actually modifying will basically be just as locked as before, but sort of the inadvertent locking of other records is now not happening when you enable this new locking schema.
So when we designed this, and this actually took 2 releases, so when you set the isolation level, that was in the wave 1 release, we wanted to put that in before we went to this, and we were kind of, oh dear, are we breaking everything? We don't know. We don't think we are. But just to be cautious.
Yes, so we have added this as a feature management switch so you can enable it. And it should be noticed, of course, things will still work. Functionally, there is no change. You still have transactional consistency, of course, but you might get another user has modified this in case you have certain code paths. We have not seen issues with this in our base app, but we cannot rule out. We can think of examples where you could get into a different behavior where you would see this, that another user has modified the record.
And this is part of, so concurrency testing is one of the most difficult ways to test code, right? That's why I put in, Jens didn't know that, but you can see this BCPT question mark in there, because there is actually a tool that can help you do concurrency tests and flesh out locking issues. So one tip here is that you enable this in sandboxes and make some scenarios in this Business Central Performance Toolkit where you are able to do concurrency tests. And that might be a good way to see whether your code is actually taking fewer locks, or if it could be that it's taking other locks, or maybe having more deadlocks, but you would be able to detect it using this BCPT tool.
Correct. And the way we're going to roll this out is that in this release, then upgraded tenants can opt in through the feature management page, as we showed before. For new tenants, this is automatically enabled, but you can flip this back and forth at will. But it is done for all users, so you don't have Kenny running with one locking scheme and Jens running with another one, but it is something that can be moved back and forth for testing, so you can also compare with and without.
Just one gotcha here. What Jens was saying with all users, you actually need a restart of the environment.
Yes.
For this switch to take effect. So just be aware of that.
Yeah, and that's in order to not mix and match these. From the next version, we will enable this by default, but you can still disable it. And then from version 25, then the new locking will be the way we do locking. Now, there are a few other performance improvements in the data stack that are worth mentioning. You might have seen that auto-increment fields made very wide tables slow. that has been optimized. There was an inefficient parameter generation algorithm that made it worse and worse. And if you had 100 fields, auto increment would actually start taking seconds. That has been fixed, and it's a lot faster now. And we've also optimized the SQL queries we generate from setRange so that SQL has a better chance of picking an optimal index. There are also a few changes that are upcoming in 2024 release wave 1. The server settings for force order and loop joins will be removed so that you don't have the opportunity to run that in the old way. This is how we've been running for years in the service. And also for on-premises, you might run with the ability to write to the app database. We will remove that possibility from the next release.
Cool. So, go-dos. The most important thing is test the new logging scheme. Try to run some BCPT tests and check for errors, check for logging or deadlocks. If maybe you don't know, but maybe go and find out if you have deleted or orphaned data that can be deleted. You can save on storage, you can save on performance. And the third thing is, if you write to the AppDB stop, in 6 months this will stop working. So this is, we're getting rid of the AppDB as a concept. So that's these changes, and this is one of the changes in that. What else should you watch? Of course, if you're watching this, you also have an interest probably in the language. So the developer tools, what's new in AL, is definitely a session worth watching. And then specifically in this series, the fourth session in the What's New in Server and Database is about reporting. But under the hood, we have some cool new things to talk about with queries. And maybe that cliffhanger, we should just leave it here.
And then just refer to the Business Central resources, take the discussions on Yammer, join the conversations on X, submit your ideas to BC Ideas, etc. And hope that we will get some good feedback on this and other things, and looking forward to hearing from you.
Thank you.
Thank you.